All right, good evening, and tonight's lesson is about prime factorization. You should be familiar right now with the word prime. Prime means, a number that only can be divided by one in itself, and you can see the word factor right here, and you know that is a number that can go into another number as a factor, so like 2 is a factor of 12. So what does it mean when we put prime factorization together? It simply means taking a composite number, which is a number that can be divided, it has many factors to it, like the number 24. All right. What we want to do is we want to take 24, a composite number. This is composite. We know this because it has many numbers that will go into it besides one in itself. It's a composite number, and we're breaking that composite down all the way to its prime numbers. So you can start off with any factor pair you want. You can do, I don't know, you could do 2 times 12. That's factor pair. 3 times 8. 4 times 6. You're not going to do 1 and 24. That's not going to help you, but you're going to use, you could use, let's see, is there any more? 2, 12, 5, nope, I think that's it. Alright, so I'm going to start actually with 4 and 6. So we know that if you multiply the 4 and 6 together, you would get 24. Now, is 4 right here, this number right here? Is this prime? Prime number? No, because it is divisible by 2, and it's also divisible by 1 and 4, so it's not prime. Is this number prime? No, neither one of those are prime, so we need to keep breaking them down until they become prime numbers. So what are the factors of 4? That's right, 2 times 2. All right, now looking at these two numbers, one right there and one right there, we'll look at this first number right here. Is 2 a prime number? It is. So when it becomes as low as it can go, you circle it. Alright, how about this 2? It is also prime. So we have stopped. We don't need to go any further because we've gone all the way down to the prime number on this side of the tree. We're going to use this called a factor tree. Over here we have 6. What are the factors of 6? Well, the only ones I can think of besides 1 and 6 are 2 and 3. Looking at each one individually, this 2 right here, is that prime? Yes, it is. Is 3 prime? Yes, because only 1 and 3 will go into 3. There are no more. These have been already broken down to prime numbers. The cool thing about this is that if you took 2 times 2 times 2 and you did snow cones, you would get back to, what do you think? I'm going to run out of room. You get to 24. Exactly. So you can check these real easily. Now, there is a special way that you have to write this, though, and it's called the prime factorization form, and it basically involves writing the numbers in increasing order. So we would start with the 2's, but how many 2's do we have? We have 2, 2, 2. So that's 2 times 2 times 2, and then times 3. Now we know right here this can be written another way using exponents. How could I write that using an exponent? 2 times itself 3 times can be written how? Yes, you guessed it, 2 to the 3rd power. I'm not having a good time writing here. Times, and there's only 1 3. So the prime factorization of 24, so we have done this, we have broken 24 all the way down to its prime numbers. Prime factorization of 24 is 2 to the 3rd times 3. Alright. And basically that's all you're doing, is you are completely breaking down the number so that all you have left are prime numbers. And this cool thing we have here, which kind of looks like a tree if you really look at it, if you go like this, guess what? It looks like a tree. So we call this our factor tree. And then if you want, because it's the holidays, you can put a star on the top. So let's try another one. Alright, let's try 108. Now, you may not know off the top of your head all the factor pairs for 108. But what we do know is this is an even number, so therefore it's always divisible by what? 2, exactly. So I'm going to go ahead and do my math over here, and I'm going to divide it by 2, and when I do, I get 5, and this is 10, and subtract, bring down my 8, it'll go into 8 4 times, 8 with no remainder. Okay, so a factor pair of 108 is 2 times 54. So I'm just going to go ahead and start my tree. Right here, 2 and 54. If I multiply this right here, if I were to multiply those numbers together, I would get 108. Now, 2, looking at this number, is it prime? It is. So we can go ahead and circle it because it's pretty much has dead-ended right there. 2 can't go anymore. 54. Well, 54 has many pairs. I'm going to go with my basic facts that I know. I know that 6 times 9 will give me 54. So, is 6 a prime number? Nope. Is 9 a prime number? Nope. Okay, that means these have to be broken more. What are the factor or a factor pair of 6? 2 times 3. Exactly. So, going back to here, is 2 a prime number? It is, so we're going to circle it. So we're done with that side. 3, is 3 a prime number? Yes, it is. We're done with that side. All right, we have to go back to this 9 because see, it's still open. It's not dead-ended yet. 9, what are the factors of 9? Factors of 9 are 9 and 1, but that's not going to work. So we're going to use 3 times 3. All right, is 3 prime? Yes. Is this 3 prime? Yes. So it looks like we have taken care of all of our branches. There are no branches that are open. So now we're just going to simply write out the prime factorization. Again, it goes in numerical order. I have 2 times 2 times 3 times 3 times 3 because I have 2, 2, 3, 3, 3. Now, how can I rewrite this using exponents? Well, look here. I have 2 2's, so I can write 2 to the second power times how many 3's? 3 to the third power. All right, pretty cool. And so therefore the prime factorization, and look at this, we made our tree again. I'm going to do it in green. We've made our tree, goes down, and you can see that our stand is actually the final answer right here, our prime factorization. Pretty cool. Now, the best thing about this is that you can always check to see if your work is correct. And I'm going to do the check next. All right, over here I'm going to do the check. That means I'm going to test 2 to the second power times 3 to the third. All right, 2 to the second power is 2 times 2, and 3 to the third is 3 times 3 times 3. Now, when I do all this math, I need to end up with 108. So let's see. 2 times 2 is 4. Bring down everything else. Bring down that. I'm bringing down this one, and I'm bringing down that one. All right, now I'll do this math. 4 times, so it's kind of like you're doing an upside-down tree. It's our snow cones. Remember those? 12 is here. I'm going to bring down this 3 and bring down this 3. 12 times 3 is 36. Okay, now we need to bring down that 3. And 3, now I'll do 36 times 3 because I really don't know that off the top of my head. 18 carry 1. 3 times 3 is 9. 108. And by golly, guess what? This is exactly what we started off with. I love it when I'm able to check my answers because that means I should never have a wrong answer. All right, we're going to do one last example. See if you can do it. All right, I want to find the prime factorization of 81. It's not even, so I can't use 2. And if you know your basic facts, you would know that a factor pair of 81 is 9 times 9. So I could use that. Another factor pair is 3 times 27. So I could use either one of those. So let's use 9 times 9. All right, put 9 here, put 9 here. Now, going back to here, we have to check. Can we circle this yet? It would have to be prime for us to circle it. Is 9 prime? 9 has the factors of 1 and 9 and 3. Remember, 3 times 3 is 9. So it is a composite number. We cannot circle it. So we have to break it further down. 2, 3 times 3. All right, how about this 9? Well, we just did that one, so hopefully you're smart enough to figure out that you're just simply going to write 3 times 3. Now let's go through. Is this prime? Yes. 3? Yes. This 3? They're all 3, so we can circle all of them. There are no leftover branches, therefore we have gotten our number all the way down, and so we need to write it in exponential form. So we have 1, 2, 3, 4. 3 times itself 4 times. So it's 3 times 3 times 3 times 3, but you have to write it in exponential form, so it's got to look like this right here. All right, count up the number you have of each number and use the exponent to represent that number. And that's basically it. So make sure you get your notes and also answer the questions so that you can get your video credit, and I'll see you tomorrow.